at t equal to 0 and amplitude 0 at t not equal to 0, such that the area under the curve delta t dt is 1. This is the definition of an impulse function, delta t. It's a complicated function. Can it be realized in laboratory? Obviously not, because you cannot have a function with infinite amplitude. Very difficult. And you cannot have a function which has no width at all. So how do we approximate it? We approximate it as follows. We say that I have a pulse whose width, this width is delta, and whose amplitude is 1 upon delta. So this is basically a rectangular function. So let me call it rectangular E by delta. This is a definition that you people have some idea of, and the amplitude is 1 upon delta. So if you take limit of delta tending to 0, then this function is delta. This is what delta is. Obviously it's a complicated function, as you can see. So what happens is, as delta becomes equal to 0, this width, it reduces in size, and because delta is small, 1 upon delta will be large, so the amplitude keeps on increasing. So eventually you get something like this, and this amplitude is infinite. So this is 0. This is what an impulse function is. Obviously it's complicated, and you obviously cannot realize it in real life in any practical laboratory. But fortunately, when we talk of a unit sample sequence, which is delta n, it's a very user-friendly function. Delta n, as I said, unit sample sequence. It is 1 for n equal to 0. It is 0 when n is not equal to 0. That's it. So this looks like this. Amplitude is 1, and this is n, and that's it. So if I make this. So the beauty of this function lies in the fact that it is very easy to define. Of course, it's slightly difficult to produce in laboratory, again because this width again is 0. But I guess probably if this width is of an order of, for this, if the width is of an order of nanoseconds, it's pretty much 0 from an engineering point of view, or maybe picosecond, it's pretty much 0 from an engineering point of view. And you can, obviously get a magnitude of 1 as the amplitude. So it is kind of physically realizable in a lab. Yeah. So you can keep your mics on mute. So this is unit sample sequence. It's very simple. What is going to be this sequence? N minus k, delta n minus k. What will this be? Can anybody tell me?
The shifted version of it.
Yeah. So this is going to be 1 when n is equal to k, and it is 0.
The delay version.
Yeah, delay version. Yeah.
Delay version of delta.
Yes, very nice. Sorry, it has gone up for some reason. Let me just make it again. So delta n minus k is going to be 1 when sorry. When n is equal to k, and it is going to be 0 when n is not equal. It's just as simple as that. There is nothing looking into it, it's a delayed version. The next function, which is important, is a unit step sequence. Now, how would this look like? How would this look like? I mean, forget about anything else. How this function will look like? This function will look like as follows. So if I have n here, I have so 0, 1, 2, 3, 4, 5, 6, 7, and so on, and everything has a magnitude. This is un. The function has values at 0, at 1, at 2. In between, it is not defined. It's not 0. It is not defined. So what? How can we write this? This is simply equal to un. It is 1 when n is greater than or equal to 0, and it is 0 otherwise. This is your unit step function or unit steps. All right. Now my question is this. How is it? So I hope these two. Okay, so let's just go like this. So these are the two functions: unit sample sequence and unit step sequence, and they are very important functions in discrete time signal processing. Let's come to probably the utility of a unit utility of unit in sample sequence. The utility of unit sample sequence is that any sequence xn can be written as a weighted sum of an unit sample train. Can anybody tell me what I mean when I say this? I said I'm talking about the utility of a unit sample sequence. I said any sequence xn can be written as a weighted sum of unit sample train. Can anybody tell me what I mean by this? Is there anyone? Okay, just let me just explain. Suppose you have n here, and I have these values. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is some x0. This is x1. I'm talking about in terms of amplitudes. So this is x2. This is x of 3. This is x of 4. And this is x of 5. It's a finite sequence. So I say any sequence can be written as a weighted sum of unit sample train. Okay. Now what I'm basically saying is that you can write xn as follows. You can say that xn is basically what is the impulse at n equal to 0? It is delta 0. And what is the amplitude at this point? It is x0. Plus what is the impulse at this point? What is it? What is the impulse at this point?
Delta n minus 1.
No, it is delta 1. This impulse is delta 1. So I'll write delta 1,
Okay.
x1, and write it like this. Then I can write it second as x2, delta 2, plus x3, delta 3, plus x4, delta 4, plus x5, delta 4. Right?
Sir,
You can also
sir,
you can also, I'm coming to that. You can always express it in terms of that n minus k form that you're talking about. Okay, let me come to that as well. What you're basically trying to say is that, you can write it as something into delta n minus k. We'll come to that. I just want to tell you that you can write it as a weighted sum of delta functions or a impulse train. So we'll come to what you're saying, I think. I hope that that is what you're trying to say. We can write it in terms of an impulse train, right?
So it should be written in that form because we are taking in comparison with n terms. If we
Yeah,
have
okay.
a
So basically, there are different ways in which you can represent. We'll come to that. It'll become clearer. Just give me some time. It'll become clearer when we do that. Okay. So the basic idea is that you should remember this thing, that any sequence can be written as a weighted sum from unit sample trains. Alright? That is what it is. Now the next thing that I want to take up, we'll come to that, Ayush. We'll just come to that in a minute. Okay. My next question to you is, how is it possible to express delta n in terms of un? Take maybe a minute, think, and let me know what will be the final expression. I just have some work. I'll just come in a minute. You just let me know what is the expression of delta n in terms of un.
कल पबजी खेलेगा
बैन नहीं हुआ भाई
भाई रात
भाई
को
अभी
रात
चल रहा है अभी
अभी मैं नहीं खेल रहा
Hello? Yeah. Can anybody tell me?
सर un minus
un minus un minus
un minus un minus 1
Can you tell me how does this come?
सर un की ट्रेन ली यूनिट स्टेप सीक्वेंस लिया उसको एक स्टेप शिफ्ट कर दिया और जो इनिशियल था एक स्टेप जो हमने इसके आगे बढ़ाया है उसको माइनस कर दिया तो वी ओनली गेट द 1 at 0 at n equal to 0.
So you basically have this, and this goes, this is your un, and then see the mic on it, and then you have a series that goes like this, and this is minus un minus 1. When you add these two, this gets cancelled by this gets cancelled by this, all of these get cancelled, and so on and so forth, and what you're going to get is basically this signal which is at 0. So basically delta n is un minus 1. This is how you can write a unit. You can write a unit sample sequence in terms of unit step functions. Okay, I think so now my question is, how can you write un in terms of express? Someone's mic is on.
Sir, Rajesh.
राजेश माइक बंद कर ले
Thank you. Express un in terms of delta n. How would that be?
So un is equals to
So del n
summation
plus del n
of k
minus 1
0 से infinity और del n minus k.
दोबारा बोलो जरा मनाली.
Sir, u bracket n is equals to summation of k to 0 और del bracket n minus k.
दोबारा बोलो.
सर
दोबारा
समेशन
बोलो.
किया है मैंने सर k से
हाँ,
0 से infinity तक और del n minus k.
Okay, del n minus. Okay, so I think this is what it is. So basically this looks like this. Actually you have, okay, so yeah, I think I just have to correct something that I did earlier, few steps back. So this is your delta n, this is your delta n minus 1, this is your delta n minus 2, this is your delta n minus 3, this is your delta n minus 4, delta n minus 5, and so on. So once you add them, this is what you get. So this is your delta n at n equal to 0, this is your delta n minus 1, and so on. So just thank you Ayush for correcting me. I think I should write n over here, I should write n minus 1 over here, I should write n minus 2 over here, I should write n minus 3 over here, and so on. N minus 4 here and n minus 5 here. So basically this is summation xk delta n minus k, where your k varies from 0 to ideally let's say infinity. Okay. K can be anything. So if it is a finite sequence, then k will be a finite sequence. So basically all these terms over here, this one is going to be delta n minus 2, this is delta n minus 3. So you basically add them and you get this expression. This is delta n plus delta n minus 1 plus delta n minus 2, and so on. So if you look at this expression also, if I consider this as some x n un, then even un, which is one of the elementary signals, is also written as a weighted sum of impulse train, except that weight over here everywhere is 1. So any signal, if you can write un as a weighted sum of an impulse train, you can write anything. So if suppose I say, just for an argument's sake, if I say that there is an xn which is given as 2, minus 1, 3, 4 and 5, and here you have you understand this arrow means that this is n equal to 0 index. So can you express this as a sum of an impulse train? What will that be? So just do that. I'll ask somebody. I don't want the same people answering anything. Aman, can you tell me what that be?
Sure, sir.
Yeah.
2 del n plus 2 minus 1 del n plus 1
So
3
n
del
plus 2
n
minus
plus 4 del n
n
minus 1
plus
plus
1.
5 del n minus 2.
Yeah. So this is what you get. Right. So you can write this impulse. You can write xn as a weighted sum of an impulse train. There is another sequence which is of importance to us, which I want to discuss. And where did I go? Yeah. Yeah. There is another sequence which is an exponential sequence. So the third sequence is an exponential sequence. And an exponential sequence is xn is something like a to the power alpha n, where a can be real or complex, but an alpha could also be like that, but in the most simple sense, we consider some very simplistic cases. So tell me now, let us say that a is greater than 0, some positive value, and alpha lies between 0 and 1. Then can you tell me how would this sequence look like? Yeah, so it will be something like this. Maybe we can start. Let's. So it will actually be a sequence that if suppose it goes, it will just probably go down like this. Right? What will happen on the this is 0 and this is n. What will happen to the n negative side? So you're talking about only the positive n, but what happens to the negative n? So this becomes 1 upon alpha. So then it will increase.
Sir,
It will go like
increase.
that. So for -1, -2, -3, it will be a function like this. Do you think that it will ever come? It will ever be equal to 0? You think it will ever go to 0?
It will tend to 0
And then it's 0.
Yeah. What happens when n tends to infinity? Basically. Okay. Now you tell me, if suppose I take if alpha lies between -1 and 0, what will the curve look like?
Depend on odd and even.
सर और पावर इन्वर्टेड होगा
So basically, so it will go something like this. It will go something like this, but it will obviously decrease in amplitude as we push into this specific value, right? And it will just be reversed where the amplitude will keep on increasing, but they will alternate increase. Can we obtain? So can you tell me how is it that I can obtain a complex? How can I obtain a cos and sine using this exponential? Can I obtain an exponential function using this? Oh, sorry. Can I obtain a cos and sine using this function a to the power alpha n? Think about it. I mean, I'm just saying that this is a very versatile function. I need to obtain exponential function. I need to obtain cos and sine. How can I obtain it using this function? That is my question.
So we can expand cos into exponential terms. We may curve like sine or cos.
You can nothing, no expansion is required. Huh?
Sir, what is the question?
To put alpha equal to a and
Second, please repeat.
My question is, what it should be? So forget about whether a is greater than 0, alpha, whatever is greater than or in some range. I'm asking you. I give you a function which is x n is a alpha to the power n. Okay. Now I'm saying, can you give me a cos and sine in xn by specifically choosing a to be something, alpha to be something, or n to be something? Can you give me a cos and sine?
you can put alpha equal to e and then
Yeah, so you can put alpha. So you basically put alpha equal to e to the power some j into omega. Do that. If you do that, you are going to get this. Okay? And obviously, I mean, a can also be. You can even put it to be something alpha not here. You can put a constant over here, and even a in the most general sense could be e to the power j phi something. And if you do that, you can get functions cos and sine. Then xn becomes a complex sequence. Xn is no longer a real sequence. Then you can obviously bifurcate xn into the real something and imaginary something, and you can get it. I hope it's clear. I don't need to do this, right? I hope it's clear. It says a naught e to the power j phi, and this becomes alpha naught to the power n and e to the power j omega naught n. So this is your xn. And if this is your xn, then this becomes a naught alpha naught n. This is a purely real number. Then you have e to the power j omega naught n plus 1. Now this is the all known e to the power j theta form, and this becomes cos theta plus j sin theta, and you get well. Just a second, I just a second. My nephew is here. Let's just break for like 2 minutes and we'll come again. I need to just send him back downstairs. Let's just a break for 2 minutes.
क्या क्या
Yeah. I hope everyone is here. Can we start?
Yes, sir.
Yeah. Okay, so these are some very basic signals that I want to talk about, and there are some other concepts that I want to talk about. Let me just. Okay. All right. So the next thing that I want to talk about. What I mean by a finite length sequence. So suppose you have xn where it is defined only for n1 to n2, where n1 and n2 can be positive or negative, doesn't matter. It is not equal to 0 for this timeline, and it is equal to 0 otherwise with a finite sequence. That is a finite sequence. So basically something like this. Suppose I say that this is n. Suppose I say this is n and I have some samples here. This is 0, this is minus 2, this is minus 1, this is 1, 2, this is 3. So you can see that xn is not equal to 0 starting from minus 2 to n to 2, and it is 0 otherwise. So this is the finite sequence.
सर ये कोई एलिमेंट्री सीक्वेंस है क्या?
This is just some example. This is some example. This is some example telling you that we are looking at finite length sequence. So finite length means that you can count the number of samples. 1 sample, 2 sample, 3 samples, 4, 5, 6. So this is a sequence with 6 samples, and otherwise it is 0. So n1 and n2 will be defined as these will be finite quantities. In this case, n1 is negative and n2 is positive. They both can be positive, they both can be negative. What is the length of such a sequence? Length of sequence is given as n2 minus n1 plus 1. So in this case, it becomes p minus 2 plus 1, which is equal to 6. 1, 2, 3, 4, 5, 6. That's the length of the sequence. So standard formula, what you need to remember, it will become very handy once we advance into the course and we go to DFTs. There and circular carbon that the length becomes important. When will the signal become infinite? It will become infinite when xn is not equal to 0. Then let's say n1 is equal to n2, and both n1 and n2 tend to infinity, or are equal to infinity, or plus minus infinity. Then we call the sequence to be infinite. My question now is an impulse train infinite sequence? is an impulse train in infinite sequence.
डेफिनेशन एक बार फिर से बताना ना,
इसका
स्टेबल हो गया था इनफाइनाइट सीक्वेंस का जो
so you know n1 and n2 both can be infinite or any one of them can be infinite. It is an infinite sequence. Why is Daksh the only one answering? Marshi,
Yes, sir.
can you tell me whether delta n minus k, this function, is an infinite sequence or finite sequence?
Yes, sir. It is an infinite sequence. So because the side is 0 and the other side is n to infinity.
What about un? Is un an infinite sequence?
So here is the definition of summation of del and minus.
So it is an infinite sequence, right?
Yes, sir.
I think this is a simple thing to understand. Thank you, Marshi. Let's go on a little further. Let's look at what we mean by right-handed sequence. Can anybody tell me what is a right-handed sequence? किसी का फैन चल रहा है. What is a right-handed sequence? नहीं, जरूरी नहीं है. That is what I want to tell you. No, tell me a general definition. It should not be right or left. Give me a general definition. It should include all. नहीं, दोबारा बोलो, आवाज ब्रेक हो रहा था. Can you tell me? Okay, so xn is right-handed. If xn is equal to 0 for n less than equal to n1. If this is the condition.
So can you speak again because
Yeah.
network issue, that's the reason.
Okay, so I'm discussing right-handed sequence, and I'm saying that a sequence is right-handed when xn is equal to 0, when n is a number which is less than n1. Now n1 is the lower index. If you look at this discussion that we have had just above here, then n1 is the lower index and n2 is the higher index. So if xn is equal to 0 for n less than equal to n1, it is a right-handed sequence. Now you understand it like this. Suppose I make a sequence like this. Suppose I say, so let's just make a, so this is your x and this is your n. Now I create a sequence like this. Okay, and it goes like this. Now
But
your n.
sir, when we say right hand sequence, then we need to n to need to tend to infinite.
Yeah. So that's what I made. I made these dots. So I'm saying that it is going on. Yeah. So I'm making these dots. It's going on. So now if I look at this sequence, then obviously this is the lower index. This is n1 here, and n2 is like going on. We don't know. It's a very high number. And you can see that for all n's less than n1, this sequence is 0. This is the right-handed sequence. Now I can also create a sequence like this. I can say that there is a sequence like this. Now is this, and this is n equal to 0. Now if I ask you, is this a right-handed sequence, what will you say?
Yes.
Yes, sir.
It is a right-handed sequence because this is your n1 here with some negative quantity, doesn't matter, but it is 0 for all n's less than n. And therefore I call this sequence as a right-handed sequence. The next thing is, what is a causal sequence? A causal sequence. Can anybody tell me?
ये जो इम्पल्स थोड़ा सा पीछे वाला सही जो इम्पल्स ट्रेन है ये भी राइट हैंडेड सीक्वेंस ही कह सकते हैं ना
कौन सा?
इम्पल्स ट्रेन इनफाइनाइट इम्पल्स ट्रेन बोल दिया
इनफाइनाइट इम्पल्स ट्रेन तो नेगेटिव में भी जा रही है इन्फिनिटी तक और पॉजिटिव में भी जा रही है इन्फिनिटी तक, तो उसको राइट हैंडेड सीक्वेंस कहना मुश्किल है, बट तुम यूनिट स्टेप को राइट हैंडेड सीक्वेंस कह सकते हो.
ओके सॉरी सर यूनिट स्टेप
unit step can be a right handed sequence, but unit impulse is going in both directions. What is a causal signal?
Sir, which does not depend on future values.
Future values or past values?
Past value.
Yes,
Yeah.
sir, past value.
Yeah. So how do we write it? It is basically you can say it is basically a subset of right handed sequence. A causal sequence is a sequence that is such that xn is equal to 0 for n less than 0. If this is the condition, a sequence is causal. So I'll say un is causal. This condition has to be satisfied that उसका कोई भी सैंपल नेगेटिव n के इंडेक्स के लिए वैल्यू हमेशा 0 होनी चाहिए, वो नॉन जीरो नहीं है. It should have no sample with a non-zero value for a negative index. That is called a causal sequence. Next is so the next thing that I want to do is what is the left-handed sequence? What would be a left-handed sequence?
n1 equal to minus infinity n1 will tend to minus infinity but n2 will be any finite.
And सर जो मतलब नेगेटिव इन्फिनिटी पे टेंड है.
xn will be 0 for n greater than or equal to n2. So then it will be a left-handed sequence, and n1 will go to as far as possible on the other side. Is this clear? So basically, it will be a sequence like this. It will be a sequence which will go like this. This is the left-handed sequence, and this is like your x. So, and this is your n2, and it is stopping here. Everything else is 0. This is your left-handed sequence. Then the next thing that comes is what is called as an anti-causal sequence. Anti-causal sequence. What is this signal? What will be an anti-causal signal? Looking at what we have been doing, can anybody tell me what is the anti-causal signal?
xn 0 for n greater than equal to 0.
xn is equal to 0 for n greater than equal to 0 is an anti-causal signal. That means no part of the signal is going to be on the right hand side of n equal to 0. Acha, अब I ask all of you a question. Is that suppose there is a sequence xn is equal to 0, okay, and n2 is less than 0. It is not equal to xn is not equal to 0. N1 tends to minus infinity. And n2 is less than 0. Is this function an anti-causal signal or is it not an anti-causal?
Anti-causal.
It can be.
It will be.
Can be sir.
It will be. No, and
It
n2 is
depends on the value of n.
no depends on the value of n2. N2 I'm giving you is less than 0.
So, but if n lies between n1 and n2, it will be a non-causal system.
If n lies between
n1 and n2.
if pick up some values.
सर मान के चलो सर n2 2 है और n1 6 है.
ना n2 2 नहीं हो सकता ना.
-2 है.
n2 -2 है
और n1 -6 है.
n1 -6 है.
हाँ,
इसको तो ये तो नेगेटिव इन्फिनिटी मान लो, लंबा है, तो ये एंटी कॉजल है.
सर अगर n की वैल्यू n2 है तो अपन मान सकते हैं. बट
वो तो
अगर
होगी। मेरा कहने का मतलब ये है कि ये जो सीक्वेंस है n2 हमेशा उसकी वैल्यू जो है ऐसा होगा सीक्वेंस, मतलब इट विल, सो दिस विल बी योर n2 एंड n1 इज समवेयर हियर। अब ये सीक्वेंस क्या हमेशा एंटी कॉजल होगा? इसके बीच में, इस रीजन के बीच में सिग्नल नॉन जीरो है या जा रहा है, बट इसके इस तरफ जीरो है, मतलब टू द राइट हैंड साइड, ऑन दिस साइड इट इज जीरो, बट ऑन दिस साइड इट इज नॉन जीरो। विल इट ऑलवेज बी एंटी कॉजल? दिस इज व्हाट आई एम आस्किंग।
सर वो होगा तो बस, मतलब अगर अपन मान के चलते फिक्स कर सकते हैं n2 और n1 को -2 और -∞ फिक्स कर सकते हैं, पर अपन अब वैल्यू अगर n की वैल्यू अपन बीच में लेते हैं कहीं पे -4 -5 वगैरह,
n की वैल्यू से मतलब नहीं है ना, मैं कह रहा हूँ।
हाँ तो सर फिर तो हो गए सर, वो तो हमेशा
it is always anti-causal so long as n2 is less than 0. That is my point. That is what I want to know. Now tell me, when would a right-handed sequence always be causal?
No, sir.
For a
Right.
no, understand what I'm asking. Listen what I'm asking. I said a sequence will always be anti-causal if n2 is less than 0. What is the condition on a sequence in terms of n1 and n2 for it to be always causal?
n1 greater than 0 and
n1, yes, n1 greater than 0. Then the function will always be causal. So these are some very tricky objective questions that are sometimes asked, which people must understand. Okay, so this is right-handed, left-handed, causal, anti-causal. You should remember that for a causal sequence, no sample of a sequence should be on the negative indexes. For an anti-causal sequence, no sample of the sequence should be with a positive n value, at a positive n value. That is anti-causal. For a causal, nothing should be on the left hand side of n equal to 0. For a causal sequence, for an anti-causal sequence, nothing should be on the right hand side of n equal to 0. These are some very standard definitions and you must remember. Okay, so let us take a, yeah.
So this means that anti-causal should always be left-handed signal.
I'm not understanding what you're saying because your voice is breaking. Can you say it again?
So it means that anti-causal system will always be left-handed signal.
Anti-causal signal is always a left-handed signal. Yes, it is always a left-handed signal. You can take any example. Try to do this as an exercise. You will find out that they are always going to be left-handed. There is a reason why I took right-handed and causal. Then I went and I said left-handed and anti-causal. That is another way for you to remember that if you're talking of an anti-causal sequence, then it always has to be left-handed. You can try out various examples.
सर आई हैव क्वेश्चन सर लेफ्ट-हैंडेड सीक्वेंस में सर n2 की वैल्यू पॉजिटिव टू नहीं हो सकती है
क्या n2 की वैल्यू?
सर लेफ्ट-हैंडेड सीक्वेंस में
लेफ्ट-हैंडेड में n2 की वैल्यू पॉजिटिव हो सकती है, बट अगर एंटी कॉजल होगा तो n2 हमेशा नेगेटिव ही होगा, या तो जीरो होगा, n2 is 0 या फिर n2 is negative. That is what I'm saying. But for a left-handed sequence, n2 can be a positive number, but the sequence will have a value 0 beyond n2, because n2 I'm considering to be a higher value than n1. That is what I'm saying.
ओके
Yeah. एक बार just try to, if you've made notes of whatever I was saying, just try to do this on some pen and paper, and you'll realize you'll get the concepts in a much better way. Sometimes it takes a little time for things to sink in. ऐसे याद रखो, right hand sequence causal, left hand sequence anti-causal. राइट हैंड सीक्वेंस वो सीक्वेंस होता है जिसमें सीक्वेंस इज 0 टू द लेफ्ट ऑफ n1. लेफ्ट हैंड सीक्वेंस होता है ऐसा जिसमें
सर ऐसे थोड़ा कॉन्ट्रडिक्शन आ सकता है, लाइक all anti-causal systems are left-handed, but not all the left-handed signals are anti-causal.
yes certainly.
Yes, sir. Yes, sir. That is answer.
Certainly because an anti-causal signal has to be entirely to the left of n equal to 0, but a left-handed sequence need not be. So an anti-causal sequence is always a left-handed sequence, but not all left-handed sequences are anti-causal. Okay, vice versa नहीं है. One is a subset of other. जैसे मैंने पढ़ाया right hand sequence, उसके बाद पढ़ाया causal. So right hand sequence is a bigger domain. Causal is a much smaller domain. Left hand sequence is a bigger domain. Anti-causal is a much smaller domain. I hope I am clear now. At least this point. Am I? Is the connection lost? Okay. So I think we'll just stop here today, and we'll proceed in the next class. I'm going to just put up some exercises. Very small. So I'm going to put up some exercises, just very small questions, and then maybe you can get those exercises tomorrow. By Monday, I'll put up the answers to them. No need to submit it, just practice a couple of problems. The problems are going to be on simple operations of addition, subtraction, multiplication of sequences, and identifying which one is right-handed, which one is left-handed. What will happen if you add one left-handed to a right-handed, or if you add a causal and an anti-causal. There will be some permutations and combinations, and no need to submit anything anywhere. I will be giving answers on Monday, and we'll also be discussing them. Monday meaning I'll give the answers on Monday, but we'll be discussing these questions later on in the next class. All right. Thank you, and good night.